All right, welcome to lesson number 4. We're going to be looking at using Z-score tables. So we're going to be looking at, or using a couple of resources that are found in your workbook, and I'll show you how to get to those. But remember, in the standard normal distribution curve as shown here, that we have numbers on the horizontal axis. So going from 0 to 3 in this direction, and going to 0 to -3 in the other direction. And so these numbers represent my Z-scores. The Z-scored tables are found on the last 2 pages, and if you look at this, this looks really complicated, but don't worry, we're gonna be looking at how to use these Z-scores and exactly what they mean. So it would be helpful if you just bookmark that, because you're gonna be referring back to it a lot in this lesson. So I just put a sticky note back there so I can access it quickly. So the Z-score table is located on the last. Those give the area to the left of a particular Z value as shown. So this area is denoted by A of Z as a function, A of Z. And let's just take a look at some of the properties of our Z-scores. So a Z-score for the data describes the number of standard deviations above or below the mean. So if I'm looking at these Z-scores and I know that my mean is 0, this would be the number of standard deviations above the mean. So a negative Z-score, that goes in this direction, and that tells you that you have a certain number of data values that are below your mean. And if it goes to the right, that tells you you have a certain number that are above the mean. The Z-score table gives you the area under the curve to the left of the Z-score, or the percentage of the data to the left of the Z-score. But also, so to the left of the Z-score, but also the probability that a random chosen data value is to the left of the Z-score. So my mean, my median, and my mode have a Z-score of 0 right here. So how do we use it? So in example number 1, we want to locate on the normal curve where Z is less than -3. So if I look at my normal curve up here, -3 is in this region right here, and so right there, this would be -3. And we want to shade this region. So this is the region that we're shading in. We want to determine the area under the curve for Z is less than -3 using the Z-score. And the table is at the back of the, and we want to do that by using the tables at the back of the workbook. And so if I were to flip back to my workbook, -3 is the value I'm looking for. And so I have -3.0 here, and I just want -3. So I know that I'm looking in this realm, but if I go to the nearest hundredth, that would be -3.00, and that would be way over here under -3.0000. And that tells me that my Z-score there, the area under my standard normal curve, is going to be 0.0013. So the way we would write this is the area of -3 is equal to 0.0013. We want to verify this answer using the standard normal distribution curve that is above. So if I'm looking at -3, the area here is 0.0013. Remember, the total area is out of 1, and so this is 0.0013. And that's good because my answer is the same. All right, so let's take a look at the class examples here. We want to use the Z-score tables to calculate what A of -2 is going to be. So first of all, A of -2 is going to be somewhere around here. So that's -2, and again, I have to reference my Z tables on the back. So I'm going to go back here. I want to find -2, and it's -2.00. So -2.00 brings me down to 0.0228. So this is equal to 0.0228 0.0228. If I'm looking for a of 1, the area under 1, it's everything over here. Reference our Z tables. And this time we're looking for positive 1, so I have to use this side. So positive 1.00 is 0.8413 equals 0.8413. A of 2, if this is 1 standard deviation, then 2 is going to be somewhere around here. Again, we reference our Z tables on the back. 0.9772. Now, remember, these are all Z scores that can be found on our normal distribution curve. So we want to verify these answers using our normal distribution curve. And when you do that, you're going to look at your curve and you're going to find that these are the same answers. But sometimes, and if you notice, there's no decimal place. I have whole numbers for each of these. But if I have negative 2.15, we're going to see that this is going to be a little bit different. So if I have negative 2 here, negative 2.15 is going to be a little further. So negative 2.15. If I want the area under this curve of negative 2.15, then I got to reference a different number. So what we want to do here is we want to find out what the area, determine the area under the curve for a standard normal distribution for each of the following Z scores, then convert each of the areas to a percentage to the nearest hundredth. So negative 2.15. I have negative 2.1 right here, but 2.1 and then 2.15 is going to be right here. 0.0158. As a percentage, I just got to move my decimal place over 2 spaces to the right, or multiply by 100, and this would be 1.58%. Well, what if I was looking for the area that is greater than negative 2.15? So remember, this was, I know that less than 2.15 was over here, but greater than 2.15 is going to be on this side. I know that if I reference 2.15 again, then I'm going to end up getting the same value of 0.0158, but I need to think about what I'm actually looking for here, right? So the area is going to become 1 minus the area of negative 2.15. And this is what I want to look for. So I'm going to have 1 minus what I found earlier, 0.0158. And we're going to get an answer of 0.9842, which is equal to 98.42%. Which makes sense, right? If I know that 1.58% is going to be below negative 2.15, then that means that the remaining 98.42% needs to be above. But what if it asked me for the area under the curve that is between, so Z is greater than negative 2.15 but less than 2.15. So I have negative 2.15 and I have positive 2.15. Well, what we're going to find is if I were to reference 2.15 in the back here, so 2.15, I get 0.9842, which is the exact same value that we found earlier. So when I'm actually writing this out, I'm looking, and this is the area that I'm trying to solve for, I'm looking for the area between 2.15, subtract the area that is less than 2.15. This is going to be 0.9842 subtract 0.0158, which is equal to 0.9684, or 96.84%. What this means is that 96.84% of my data is going to fall in between negative 2.15 and 2.15 standard deviations. And with class example 4 and 5, we would approach these the exact same way I did these 3 questions. So I'm going to leave these ones here for you to complete, but we are going to look at class example number 6. So we can also use our z-score tables in reverse. So if I have the z-score, we can determine a z-score when an area under the normal curve is given. So if we can do that, let's determine, we want to find out what z1 is and z2 in these the examples below. So in order to find z1, I'm looking for the area of z1. And I know that the area of z1 is equal to 17.62%, or 0.1762. So what I'm looking for is a value that has a z-score, or a z-score of 0.1762, which will give me my z-score. So 0.1762. So let's look over here first of all. So 0.1762. Down here I'm at 0.16. I'm going to look around here. So 0.17, 0.1736, 0.1762 corresponds to negative 0.9 and negative 0.9 all the way up to negative 0.93. So this is equal to negative 0.93 for my z-score. If I'm looking for on the other side, I'm looking for the area above Z1. And so to find the area above Z1, we actually, remember, have to subtract this area here. So I have to have 1 subtract the area of Z1. And this is going to become, and then we know that this is equal to 0.1492 because we're told up there. So 1 minus 0, if I were to switch places here to solve for this, I'm going to be left with, if I rearrange this algebraically, I would add a of z1 to the other side and subtract my 0.1492 over here, which becomes 1 subtract 1492 is equal to a of z1. This is going to equal 0.8508. So we actually don't even have to look up the z-score here yet. But now I know that the area of Z1 is equal to 0.8508, which means that my z-score is going to be 0.8508. And that, since that's pretty big, it must be positive. 0.8508 is right here, so 1.04, so 1.04, 1.04, 1.04. All right, in my last 2 examples, I'm looking for Z1, and Z1 is in between 0 and 0.2580, and that's the area under my curve. And so a of Z1 minus a of 0 is going to be equal to 0.2580, 0.2580. So AZ1 minus a of 0, and if we look at what a of 0 is, check it out, a of 0, 0 is 0.5. 0.5 is equal to 0.2580. And if we rearrange this algebraically, all you got to do is add this 0.5 to this other side, and I have AZ1 is equal to 0.7580. So, sorry, I keep writing A there. I just want Z1. So my Z-score here 0.7580. Again, pretty big number. 0.7580 is going to be 0.7. So my z-score here is equal to 0.70. And my last one. Okay, so in this last example, I want to find the areas in this shaded region and in this shaded region. So I have Z1 and Z2 that I'm looking for. So first of all, area of, in order to find this one, we first want to find the area of Z2. So area of Z2 is equal to, again, 0, which we found out was 0.5, minus this 0.1292. So my area of Z2 is equal to 0.3708 and 0.3708 if we reference that. 0.3708 is pretty close to 0.3707. So that would be negative 0.33. And the area of Z1 is equal to, well, we know that the z-score here was 0.3708. Subtract 0.2145, and that is equal to 0.1563, and that's A of Z1. So if we look at 0.1563, we're around here, and that's going to be negative 1.1. So negative 1.01. And that's the closest z-score we get there.